Today I will show you a novel authentication mechanism. It's an extension of the OAuth2 protocol. So let's look first, have a view over how the classical OAuth2 protocol is. What is the mechanism? So you have here the user, you have the client app, which can have a server component too, but for now we will just abstract it under client app. And this is the OAuth2 server, and this would be the resource server that contains the confidential information that the user will be presented with. So the OAuth mechanism starts with this PKCE mechanism where you generate something called a code verifier, and then you hash this code verifier string and you get a hash. And this is the hash that the client app first sends to the OAuth server along with a generated state string and client ID, and of course the redirect URL that this OAuth server needs to redirect to after the user logs in. So the code challenge is the hash of this code verifier, and the OAuth server receives all of this information and then presents the login and consent UI to the user. After the user gives its credentials and it gives consent, then the OAuth server sends to this client app an authorization code. So this is a temporary code and the state that it has received here. So then the client app can verify that the state is equal to what it generated. So this authorization code is indeed from the OAuth server that it intended to talk with. And then with this authorization code, it needs to get a long-lived access code and maybe a refresh token. So then it sends this authorization code, another redirect URL, the client ID, the client's secret if it has a server component, a confidential server component, and the code verifier. So right now it sends the actual string that it generated here, and on the OAuth server side it will validate this code verifier and compare it with the hash that it received at this point when it produced the authorization code. So it makes sure that it gives the token access to the same client application that started this OAuth process. And then this access token, refresh token, is given to the client application, and client application will use the access token to request the protected resource, and it will use the refresh token whenever it wants to refresh this long-lived access token. So this is the classical OAuth mechanism. Now, I've brought this mechanism to be used in the context of blockchains, and my wasmX chain, wasmX blockchain engine, can be used to have chains that have HTTP servers, that have OAuth mechanisms, and much more. So what I've done here is to create a way for users to interact with the chain without even knowing that they are interacting with a blockchain. What they do is create an account, sign in as with any other OAuth2 provider, and then they can post transactions to the blockchain, and the transactions will be executed on the blockchain on their behalf. So what is different are these parts. So here, when the client application will be receiving an access token and refresh token from the OAuth server, the OAuth server of wasmX additionally creates an ephemeral key pair. So this is a private public key pair, and it links it to the access token, and then it registers the corresponding address in the user's identity. So this registration is an on-chain transaction. This OAuth server which is hosted on the wasmX chain, this is actually a smart contract in Wasm. And the research server, it's also the wasmX chain. It's it's the actual blockchain. So it's whatever smart contract the user essentially wants to interact with and wants to change state. So the OAuth server contract creates an ephemeral key pair for the user and registers the new address in the user's identity. So essentially, the OAuth server will create transactions with this ephemeral key on behalf of the user. So now the client application can make transactions on behalf of the user only using this access token from the OAuth mechanism. So it makes a post on sign and broadcast. This is a special endpoint. And then the OAuth server gets the ephemeral key linked to the access token and signs the transaction. And it broadcasts the transaction to wasmX. Then the chain returns the transaction hash and it's forwarded to the user. And of course, because this is an ephemeral key, whenever you use the refresh token to create another access token, this ephemeral key is removed, deregistered from the user identity, and a new ephemeral key pair is created. It's linked to the new access token and registered in the user's identity. So the OAuth server, the contract itself, is non-deterministic. So it's not part of the deterministic storage in this chain. This is a non-deterministic contract, and it has its own private key with which it can sign transactions. So that's how it can register in the wasmX identity contract. It can register this additional ephemeral address for the user. So this is the mechanism explained. And now, well, we can actually try it. So this is an explorer that I am serving from the chain itself. I have a static HTTP server that is managed by contracts. So this is a local Mythos chain. This is a simple storage identity. It's like a simple storage contract, but the user has multiple addresses linked to its identity. So I can use any of those addresses to make changes in this contract, and it doesn't matter because the changes are applied to the user ID. So right now, we can go to Nomen. This is the way we log in. The Nomen app aggregates various third-party providers that we have, like Google, GitHub, LinkedIn, and wasmX. This is our OAuth mechanism. So what we're going to do here actually is go to the register route, and it knows that we are logged in with Nomen on this email address. So now we can just put the username, and we will need a PIN, right? This pair of private public keys will be stored in this browser in the local storage. And this is a PIN with which we encrypt, let's say 1, 2, 3, 4. So this is the first time that we actually create a user account on wasmX for this user. So we are going to register, and a lot of things are happening in the background. We can also see some logs here. I have some quite ugly logs, but we can see where the identity is registered. It generated a user ID, which is user2, and so on. So now we have a wasmX account, and we can register it with Nomen. So we click on this wasmX, and we authorize. And now we have it connected. This means that this Nomen application has our access token. So Let's do a refresh here, and we will see the actual address that was created in the browser. So this is from the public-private key that was created when we registered the account. So we can actually use it. It's in the browser. We can use it to execute transactions. So now the query will be done on behalf of this address. And it tells us that we have no data stored in this simple storage identity contract. So we can just store something. Let's store BBB. And we click on execute transaction. We are putting in our PIN. So our private key can be decoded and the transaction is sent. We can see the transaction hash here. We can see it in a new tab. Okay. And we can see, that the sender is our address here from our private key. So let's load, and we see BBB. This is the state for our user now. So what now? If we go to another browser, to the same simple storage identity contract. We are not yet logged in with Nomen at this point, and this is a default address that we will use for queries because we don't have any associated private key or address for our user. So what we are going to do now is sign in with Nomen, on the same account that we just registered, and we see that we have wasmX here. Now let's refresh this Explorer page, and we will be storing another value with W this time, and we will execute with Nomen because we've logged in with our user. Nomen is able to actually send a transaction on our behalf. And this is the ephemeral address that was created by the OAuth system. To verify what has happened here, let's go back to our original account, right? In the first browser. So now, when we load again, we see it's www. So even though it was the second transaction was sent from an ephemeral address through the OAuth system, it changed the user's state in the contract by user ID. And we can also look at the logs from the blockchain. This is the first user registration with the first key pair. This is where the ephemeral key was generated for user 2, and this is the access token that was generated and mapped to this public private key. So keep in mind, this contract stores data per user. So we have www for our user, and we will copy this address. And if we go to the other browser where we do not have a key pair in the browser, and this is just a default address, if we go to load and we call the query, we see there is no data because there is no data for this user. If we put the address of our key that was used when we registered, we indeed see the www data. And now, if we get this address, which is our ephemeral key address, and we again put it here and we query it, we get the same www data because the two addresses point to the same user. And any other address that we use here will have the state as unset. So what I've shown you today is that you can transfer authority from HTTPS and OAuth to transaction signing on a blockchain. So as a user, I don't even know that I am interacting with a blockchain.